Hey everyone, today we're going over sigma notation and what it is and what it's used for. We're going to get started by drawing what the sigma symbol looks like. This little symbol that looks like kind of a real straight sideways M is a capital sigma. And what it means is repeat sums. We're going to keep adding things over and over and over again. And we have a special notation for that, and we're going to start off with easy, and I'm going to do about, 4 or 5 examples, and we'll see what it looks like. So we start off with a sigma of I equals 1 to 5 of I. And because it's a repeat, it wants us to kind of do like a little loop, do something over and over and over again. So this notation with I means we want I to start at 1, and then we're going to repeat, going up by 1 each time, until I gets to 5. So what it ends up looking like is something like this. We begin with I as 1, and it's a repeat sum. So we go to the next I, which is 2, and the next I, which is 3, and the next I, which is 4, and the last I, which is 5, and then we stop. Because on top of the sigma symbol, we put a little 5. So it means we start at 1, go until we get to 5, add them all up, and we get 15. That's what this sigma is telling us. It wants us to repeat sums, repeat addition, over and over and over. We can not start at 1. We instead could say I equals 3 to 5 of I. Oh, in this case, I doesn't begin at 1. I begins at 3. And we still go up by 1s each time. So we have 3 plus 4 plus 5. And this time it equals 12. This is the little bit start of sigma. Let's try something a little more trickier. So what's different this time is we have a list of numbers. We have 5 numbers in our list. Our first number, second number, third number, fourth, and fifth. And we can show our notation for these numbers by saying that our first number is x1, x2, x3, x4, and x5. That means it's the first number in the list, the second number, and so on. Now this time we're going to change our sigma notation. We're still going to write our capital sigma. We're still going to say I equals 1 to 3 this time. But instead of putting an I here, I'm going to put in xi. The I is still going to start at 1 and go up by 1 each time until it gets to 3. But instead of just being an I, it's going to be our term. So x1, x2, x3. So in this case, our x1 becomes our x1 plus x2 plus x3, which is going to equal our 3 plus 5 plus 7, which equals 15. So in this case, instead of just using an I, we turned our little i's into a term number, our x1, our x2, and our x3. Another little fancy thing we can do with sigma is we can begin I as 1, and on top we put an N. Oh no, it's not even a number this time, it's a letter. If you ever see something that looks like this, sigma beginning at I equals 1 and going to N, that just means go until the end of a list. We have a list of numbers. You may not know what the total length of that list is until you start the question, but this little equation here just means add up every number in this list. You start with I equals 1 and go to the very last number. So it will be 3 plus 5 plus 7 plus 9 plus 11, and we can add all of those up, and it's going to equal 35. I'm going to do one last fun little example just to show that there's one extra shenanigan. There's a few extra shenanigans. This will get you started. I'm still going to write a sigma. I'm still going to go I equals 1 to N. That means I'm going to begin at the first, go until the end of some list. And this is our list. It only has 5 numbers in it. I did it small. It's bite size. But instead of xi, I'm going to write xi squared. Haha, it's supposed to be extra fun. It means we take each number, square it, and then add it. So it will end up looking like this. 3 squared plus 5 squared plus 7 squared plus 9 squared plus 11 squared. So we're squaring them each time now. We can still then, now that these are squared, we can put this into our calculator, add this up, and it's going to equal 285. And all this is showing is that it doesn't just have to be an I in the sigma notation. It doesn't just have to be an xi in the sigma notation. We can actually do extra operators to our xi. But at the end of the day, you always just begin at whatever I it says and go until, repeat adding, you get to the number on top. I hope that this was helpful and it explained sigma notation for you. If you have any questions, please feel free to leave them in the comments below.